Okay, so welcome back. So correspondingly, in the today's session, we are going to start with the new practical, next practical, that is experiment number 2, that is determination of Los Angeles abrasion value. Okay, in the previous practical, we have seen the aggregate impact value of the aggregate. So second test which is required to be conducted on the said aggregate is nothing but Los Angeles abrasion value, that is determination of Los Angeles abrasion value. Okay, so it is as per IS 2386 part 4 1963. Okay, just I will share the screen. Okay, so in the previous session we have seen that there is one code which deals with the provision which is been made in order to test the aggregates. So that IS code is nothing but IS 2386 part 4 1963. Okay, so as per that only we are going to test the aggregate for abrasion. So basically we are knowing that aggregates undergo significant wear and tear throughout their life. Okay, so they are being used in surface course of the highway pavements which are subjected to wearing due to movement. Okay, of the traffic. Okay, so whenever the vehicles are been moving over the said surface, so the correspondingly whomsoever are the aggregates, whichever the aggregates are present on the top, they get crushed. Okay, so correspondingly due to the presence of the soil particles between the pneumatic tires and the road surfaces, that causes certain abrasion of the road aggregates. Okay, and we should know that whenever the aggregate is supposed to be recommended for the use of construction of the road, so it should be hard and tough enough to resist the crushing, degradation, and disintegration, and should be able to transmit the loads from the pavement surface to the underlying layers and eventually to the subgrade, that is from top layer to the bottom layer. So correspondingly, whomsoever is the bottom layer, that is sub base course, is only strong, it is not the criteria that it is good for the transportation. Okay, so all the courses, that whatever the material you are going to use for the construction, they should be strong enough. Okay, so for this purpose we are conducting this Los Angeles abrasion test. Okay, so the basic principle of the mechanical or the mechanical property of the aggregate required in any construction is to satisfy resistance to crushing under the roller during the construction, as well as adequate resistance to surface abrasion under traffic. So as I told you that in the road construction, they should be strong enough to resist the abrasion and crushing under traffic wheel load. Okay, and if they are weak, okay, so the stability of the pavement gets adversely affected, or certain potholes takes place, or correspondingly there is sudden failure, or there is certain cracks are being formed. Okay, so if the aggregates are used in such a manner without taking the test of abrasion, so it may cause premature failure or loss of skid or resistance of the pavement. Okay, so for that purpose we are making this. So basically you are supposed to check that whenever, so how you are going to check the abrasion test, that so you are having one instrument, that is nothing but Los Angeles abrasion. Okay, so in which the standard steel balls, or we can call it as the Abrasion charges, so which are made up of steel, so that are supposed to be inserted. So I will just show you the pictorial image. So this is nothing but the said Los Angeles abrasion testing machine. Okay, so in which such kind of abrasive charges, okay, are supposed to be inserted in order to check the aggregates against the abrasion testing. Okay, so we'll see one by one. So the what we are going to do, okay, so basically the aggregates along with this steel balls or abrasive charges, okay, we are going to insert in the Los Angeles, we are going to rotate it as per the standards which are being given by the IS 2386 part 4. Okay, and as per the rotations, whether it is 500 or 1000 rotations, okay, we are going to calculate the percentage wear of the aggregates due to rubbing with steel balls. Okay, and that whatever the percentage we get, that is the wear of the aggregates, that is nothing but called as Los Angeles abrasion value. Okay, so the objectives of the said practical which we are going to conduct is nothing but to determine the Los Angeles abrasion value. Okay, and to find out the suitability of the aggregates for its use in road construction. So unless and until we are knowing that if it is not having a proper strength or adequate strength, we cannot recommend that particular aggregate for the said construction. So this is the objectives. Okay, so here you can see the image. Okay, which is showing the overall. This is nothing but the line diagram of the Los Angeles. Okay, so this is nothing but the said Los Angeles abrasion machine. So which is consisting of hollow steel cylinder. Okay, so which is closed at both the ends. Okay, and with an internal diameter of correspondingly 700 mm and length is 500 mm. You can see it here. Okay, just a minute. I'll mark it here. Yeah. Sorry. Okay. So here you can see the total length is 500 and inside diameter is 700 mm. Okay. Correspondingly, there is a shelf. Okay, and it rotates about its correspondingly horizontal axis. Okay. So this figure shows correspondingly the assembly of the said Los Angeles. Okay. So correspondingly, correspondingly a cover has been provided at one side. So this here you can see the cut section of that cylinder. So here is one cover plate which has been provided in through which we can insert the aggregates which are supposed to be tested along with the steel charges or the abrasive charges. Okay, got it. And a tray is been inserted below that whenever the test takes place after rotating the 500 or 1000 revolutions. So what is the 500, why you are going to make 500 revolutions or 1000 revolutions, I will tell you. Okay, so after that what happens, whatever is the dust that is been collected or whatever the crushing of the aggregates are taking place due to the rotation of this said steel cylinder. Okay, so it should be collected in the tray. Okay, so it has been provided over a support. Okay, so inside this you can see the average charges and aggregates are there, so which makes an impact correspondingly, or they fall over each other, and due to which certain crushing takes place. Okay, got it. So this is the pictorial image of the Los Angeles. So this is the cover, so which has been fixed by the bolt. So through which I told you the steel charges or the abrasions can be inserted. So here is the rotate counting device. Okay, so after one revolution, number automatically here it is one, then two, three, four. According to that, goes on counting it. Here is the motor. Okay, so according to that, we can operate it. Okay, so basically for conducting this practical, as I told you, we require Los Angeles machine. So the description of that I have told you right now, that is nothing but the Los Angeles abrasion machine. Okay, so which consists of diameter 700 mm, inside length is 500 mm. So this cylinder is been mounted on the shafts, okay, which is closed on both the sides and which rotates about its horizontal axis. Okay, got it. Correspondingly, the opening, that is this cover which we are going to provide, so it should be such that whenever the rotation takes place, the dust which has been formed due to the contact of the aggregates and that of the steel balls, they don't come outside. So it should be dust proof. Okay, so it's corresponding, it should be dust tight with a removable cover bolted in place. Okay, so correspondingly, the cover shall be designed as to maintain the cylindrical contour of the interior surface unless the shelf is so located. Okay, and again, correspondingly, one thing I would like to tell that how the action is going to take place. Okay, so here you can see a steel shelf has been provided. So this is nothing but the cylinder, So inside this one steel shelf is been provided. Why is it so? Because whenever the rotation action will takes place, okay, the balls, the steel charges or the abrasive charges which are going to transfer along this surface, when they will come at certain stage, that they will fall over the aggregates. They are present here. So here you can see the image. Okay, so they are going to fall over the said aggregates. Okay, so there is an abrasion. Okay, so for that purpose the steel element is been provided, steel shelf has been provided. Okay, so which is running throughout the length of the said our cylinder. Okay, then correspondingly the shelf is placed at a distance of 250 mm minimum from the opening. Okay, then we require the next instrument for conducting the seed practical, that is abrasion, ISU of 1.7 mm. Okay, then abrasive charges, so which are 48 mm in diameter and each weigh correspondingly 390 grams to 444 445 grams. Balance of capacity 5 kg to 10 kg. Okay, then we require an oven so that whenever you are going to test the aggregate, so it should be properly dried, and miscellaneous like tray which I have shown you in the initial only pictorial sketch, so which is required in order to collect whatever the dust which has been just done after the test which has been formed, that can be collected in order to calculate proper abrasion value or the percentage. Okay, now as I, you might have a question in your mind that why only 1.7 mm ISU is required and why not others? Okay, so basically the grading of the aggregate takes place, and according to that only we are supposed to make use of the ISUs, and that only ISUs that are been told to you as per the IS 486, corresponding that IS code 2386 1963 part 4. Okay, and we are supposed to pass from that and then get on written, and correspondingly sample what is the weight of the aggregate which is required for the seed. It depends upon that grading of the aggregate. Okay, so that is nothing but preparation of the test sample. So whatever the aggregate we are going to make use of that, so it should be dried in oven at a temperature of 105 to 110 degrees Celsius. Okay, and as per the table 2, that is nothing but the as per the IS code. Okay, so this is the grading of the test samples. Okay, so this is A, B, C, D, E, F, G. Okay, so they are telling that correspondingly, whenever you are going to make use of the grades A, B, C, and D. Okay, so if you are going to add this total, so 1250, 1250, 1250, 1250, so it comes out to be total 10,000. Okay, grams. So that is nothing but 10 kg. So for B also it is correspondingly, so it is coming out to be further, it is coming out to be something. Okay, sorry, so for A B C D it is 5 kg, sorry. Okay, grades, and for E F G it is 10 kg required for gradings of the aggregate. So suppose I am interested in going with the grade of the aggregate as A, so total I will requiring sample, test sample is 5 kg, and they are telling that you are supposed to pass through 40 mm and retain on 25 mm. So this much amount of aggregate I am going to take. Then again passing through 25 mm, retain on 20 mm. This 1250 gram I am requiring. Again passing through 20 mm, retaining on 12.5 mm. This 1250 gram again, and again passing through 12.5 mm and retain on 10 mm. So this is the classification of correspondingly. So you will be requiring 25 mm, 20 mm, 12.5 and 10 mm ISU. Okay, for grade A. For grade B of test sample, you will be requiring only 20 and 12.5 and 10 mm. Okay, so here you can see passing through 20 mm, written on 12.5 mm. It is for so sample required is 2.5 kg, and passing through 12.5 and written on 10 mm, it is requiring 2.5 kg. Okay, so likewise as per the grade of the aggregate you are going to test or take for checking the abrasion test. Likewise, you are going to take the consideration of ISCUs. Okay. Then first of all, we'll select the grading. Then, as I told you, 5 kg is required for A, B, C, D, and 10 kg for E, F, G. So after taking the sample, okay, now as per that, okay, grading of the aggregate, okay, we are going to take the number of abrasive charges. So these are nothing but the abrasive charges. Okay. So as I told you, these abrasive charges are nothing but correspondingly which are 48 in diameter. Okay. And they are weighing approximately 390 grams to 445 grams each of this ball. Okay. So if I'm going to take the grade of aggregate as A, so I will be requiring 12 number of steel balls, or we can call it as spears or abrasive charges. So which will correspond to weight 5,000 plus or minus 25. Okay, so it is given as per the IS code only. Okay, so if I'm going to make use of the grade B, it is 11 number of spears. Then if it is C grade, the number of balls to be used, it is 8 only. Okay, so likewise, whatever is the grade, you are going to take the number of balls. Okay, so now after that, after selecting the grade of the aggregate, and according to that, you are going to take the number of charges. Okay, then you are going to open the cover and feed the aggregates and steel balls in the cylinder. That is correspondingly, you are going to open this cover, and along with the steel balls or the abrasive charges, you are going to insert. Suppose I am interested in taking the grade as B. Okay, so I will be taking the sample passing from 20 and written on 12.5. Okay, written on correspondingly 12.5. So the total quantity will be 2.5 kg. Again, the correspondingly the aggregates which are passing from 12.5 and written on 10 it will be 2.5 kg. So total 5 kg I am going to take, that I am going to insert in the this cylinder through this cover, and along with that the steel balls or the abrasive charges which are required. Okay, so for B grade it is 11 charges or spears are required, that also I am going to insert it. Okay, so you are going to fix it, tight the bolts. Okay, so you are going to tight the bolts so that whatever is the dust which is going to form inside the cylinder, they will not, it will not come outside. Now, as per the IS 2386 1963 part 4, they are telling that you are supposed to give certain revolutions. So it is 500 revolutions for the grades A, B, C, and D, and 1000 revolutions for E, F, and G. So at a rate of 30 to 33 revolutions per minute. Okay. So after achieving total revolutions, so as we are chosen B grade, so 500 revolutions are supposed to be done, and after desired number of revolutions we are going to stop the machine and remove the dust cover and take out the material. Okay, and after that we are going to take out the steel balls, that is the abrasive charges, and whatever is the material that we are going to sieve through the 1.7 and whatever the material which is going to retain over the 1.7 that we are going to wash it, dry it in the oven, and we are going to measure it up to an accuracy of 1 gram. Okay, and then we are going to calculate the percentage of loss of material. Another sample we are going to take it, follow the same procedure, and we are going to calculate the average of that. So that is nothing but the Los Angeles abrasion value. Okay, so what precautions we are going to take it, so that the cover should be fixed tightly before rotating the machine, and correspondingly all the material should be discharged from the cylinder after the conduct of the test. So this is the observation table. So original weight which I have taken, it was 5,000 kg for the grade B. So I am going to write it here. So the material which has been retained after giving the rotations of 500, so which is retained on 1.70 ISU, that will be, I will be writing here. So that difference of that will be loss of weight. Okay, so W1 minus W2 divided by W1 into 100, I will get the abrasion value. Okay, so we are going to take two samples. So sample 1, sample 2, and according to that we are going to calculate. So whatever is the mean, that I am going to write it here. And after all that, the Los Angeles abrasion value will be written here. Okay, so as per whatever is the aberration value we are going to get after conducting this test. Okay, so as per IS 2386/1963 part 4, they are telling that when you are going to use for a particular type of payment, the maximum permissible aberration value in percentage is this much. So if you are going to go for waterbound macadam sub-base course, so it should be at least 60% maximum. It is permissible. So it is, suppose WBM base course with bituminous surfacing, it is 50%. For bituminous bound macadam, it is 50. Then WBM surfacing course, it is 40, and so on. And according to that, you are going to write down the result and conclusion. Okay. So for a better understanding, I will show you the video. 1 minute, I will show you. Okay. So this is nothing but the, here you can see, this is the Los Angeles abrasion machine, so which rotates. Here you can see. Okay, so the abrasion charges falls over the aggregates. Okay, got it. So this is nothing but the steel shelf. Okay, so whenever, so as I told you, it should be minimum 1250 mm. Okay, from the opening. So these are the steel charges, abrasion charges. So here you can see. So after, when it reaches upside, the ball comes falls downside, and the aggregates which are present there, they gets an abrasion. Okay, so that is nothing but the, so this is the test. Okay, so here you can visit the website of the NIT virtual lab for the transportation. Okay, and make a practice of such a case. Okay, so here also you can get stepwise what we are discussed right now. Okay, so correspondingly, step 1 is nothing but selecting the grade. Okay, then correspondingly, sample required is 5000 kg. So number of spares, it is 12 written, but if you go on correspondingly visiting the IS code, it is written 11. So first of all, I'm going to pour the sample over the 20 mm. Then by making of the IS sewer, whatever is the amount required as per the said, 2.5 kg returning on 12.5, and 2.5 kg returning on 10 mm. That sample I'm going to divide it. So in all total will be 5000 grams. So that is W1 original. Then correspondingly, I'm going to open the cover, insert the abrasion charges and the aggregate, and give the rotations. Okay. So at a rate of 30 to 33 revolutions per minute. So 500 R is required for grade B. Okay. Then correspondingly, whatever is the material after 500 revolutions, I'm going to take it out and pass through the 1.7 mm, and whatever is written, okay, that I'm going to wait. So suppose it is going to come out to be 2650 grams. Okay, so it will be W2. So the difference of that, I will get W1 minus W2. Okay, divided by W1, that is the original weight, multiplied by 100. So it is coming out to be 47%. Okay, so for 47% value, when you are going to interpret, so it is good for correspondingly bituminous bound macadam, then WBM base course with bituminous surfacing, and waterbound macadam sub-base course. So that we are going to write it here. So the mean of the two results to the nearest whole number is something 47, and conclusion, it can be used as it is within the permissible aberration value. So it can be recommended for waterbound macadam sub-base course, WBM base course with bituminous surfacing, and bituminous bound macadam. Okay, so this was regarding the today's practical session, that is determination of Los Angeles abrasion test. Okay, so in the next video we'll see how the correspondingly actual video of Los Angeles abrasion test is been conducted, and we'll do the calculation. Okay, so we'll stop it here. Thank you.